Hi, and welcome back to Integrated Science. I'm Miss Sparks, and today we're going to finish up talking about Newton's three laws of motion. So we've talked about Newton's first law: an object in motion stays in motion, an object at rest stays at rest. And we talked about balance and unbalance and net forces. So remember, net force is the total force acting on an object, and then a balance is when it is equal on all sides. So normally that means that it is stationary or moving at a constant speed. And if it's unbalanced, then it is moving in one direction, up, down, left, right, forward, backwards, whatever it may be. But the one force is much greater than the other forces acting on an object. Then we talked about Newton's second law of motion, which is the idea that as you increase the acceleration, or if you increase the mass, or if you decrease the mass and increase the acceleration, forces are going to have to change in order for that object to stay in motion. So Newton's second law really has to do with unbalanced forces, but we're looking at what that force has to be greater or less than when it is applied to an object that has a certain mass, and then what is the acceleration we want it to achieve. And then we also talked about impulse and momentum. And momentum is the idea, once again, that when objects have a mass, their velocity can be pushed in a certain direction, very similar to our force. So you might remember my 2T charts that we kind of talked about. Those two kind of come hand in hand. And then impulse is when objects collide and the movement is somehow going to change. And that leads us then into Newton's third law of motion, is how does that impulse kind of work? So my apologies, I thought I was in the right slide. All right, so let's get started. So make sure that you get out a sheet of paper and take down some notes today of Newton's third law. Luckily, hooray, there is no actual equation. We are just going to be working on what is the action and reaction that is happening. So Newton's third law has a very rhyming type of saying, just like Newton's first law does. So that's kind of nice. And you've probably heard it before. For every action, there is a reaction equal in strength and opposite in the direction. So we're looking at action and reaction, action and reaction. So what's occurring is that we're now taking into account the total energy or the total forces that are acting on an object. So if we look at this picture here, we can see there's a weight, a 1 kilogram weight that is on the floor. It says it's on the floor. And the floor is pushing up on the weight at 9.8. We've heard that term before. That's gravity here on Earth that is pushing upwards. And then clearly, obviously, this weight isn't hovering above the floor or anything. So we also have a gravitational weight of 9.8 pushing back. So 9.8 pushing up, 9.8 pushing back. Nothing is happening. There's an equal reaction. It's being pushed up, it's being pushed down. You sitting in your chair right now is the same idea, is that you're pushing down on the chair is pushing back up on you, and we can even take it even further. The floor is pushing on the chair, which then is pushing on you. So there's all these different types of things that come into play. We can make it unbalanced though too, so we can make an opposite reaction too. So if I came over and kicked the chair out from underneath you, that would be an opposite reaction, and then you would fall down to the floor and we would all laugh at you. Just kidding. Maybe we would come help you up. Of course, I wouldn't do that. I wouldn't be that mean. So, action, reaction. These are the terms that we're going to be using when we talk about Newton's third law of action. What is the energy, or what is the force that is coming out, and what is the action that is reoccurring with it? So, let me pull up. There we go. So there's your underlined portion, but let's kind of talk about all of this here. So action, reaction, those are the words for the day. So Newton's first two laws of motion explain how the motion of a single object changes. So just one single option. Whereas Newton's third law, we are going to incorporate all different types of things that are going to kind of happen with that. So that's what this is saying here. Newton's third law describes something else that happens when one object exerts a force on another object. So it's kind of that, once again, that impulse sometimes. It could be two colliding, or it could just be me pushing a cart at the grocery store, or a roller coaster being pulled up a hill, or you riding your bike and pushing down on the pedals. Whatever it may be, there's going to be an exerted force on another object, and we're going to see what that is. So even like, once again, my neighborhood seems, for whatever reason, skateboarding seems to be the thing that everyone wants to be doing right now. I feel like I see kids up and down the street all day long skateboarding. So that is a great example of Newton's third law of motion, is that you are on the skateboard, and when you push your foot down onto the ground, you're causing an opposite reaction. It's pushing off and allowing the skateboard to go forward. So according to Newton's third law of motion, force always acts. I feel like I need to move my floating head here. So according to Newton's third law of motion, force always acts in equal or balanced, but sometimes opposite, unbalanced pairs. So even though I'm standing on the skateboard, I'm balanced, but I'm causing an unbalanced force every time I put my foot down on the ground and push off. That's causing an unbalanced force, which then allows me to go forward. But I'm balanced because technically I'm standing on the skateboard. If I become unbalanced and I fall off, which that would be more likely the case, but we'll save those stories for another day. So forces exerted by two objects on each other are often called our action-reaction force pairs, and that's what we're going to be talking about. So once again, forces exerted by two objects on each other. Your foot pushing down on the ground pushing back down on you. Action-reaction. The action is you push down, the reaction is you're able to push forward, taking that momentum with you. Either force can be considered the action force or the reaction force, however you want to look at it. So there's not like a perfect right or wrong. Sometimes we're just going to say this is what we think is happening first. Here's what came second. Kind of like the chicken and the egg argument. We don't really know, but we're just going to say we know this is now being applied to this, and there's our action, and then there's our reaction. And then we can also say action and reaction force pairs don't cancel because they act on different objects. So it's not like they are colliding and then just stopping. There's something that's happening. They're making a different types of movement. They're causing each other. It's like a chain of events that is occurring, if you want to think about it that way. Forces exerted by two objects on each other are often called, I feel like we just read that. We did. Nope, we're good. The force exerted by two objects on each other are often called the action-reaction pair. And then I'm going to jump down to this one. Action and reaction pairs don't cancel because they act on different objects. Once again, that action on different objects. So let's take, this one's NASA here, but I feel like if you've been paying attention to the news more recently, Elon Musk's company, SpaceX, has been very, very, very successful. They launched a rocket, Falcon 9, Falcon Heavy, up into space a couple of months ago, I want to say it was. And with that, there were two astronauts that actually ended up docking with the International Space Station. So they had to go through a series of tests to test their different rockets to figure out which one worked the best. So they've done some really interesting stuff with their company, and we will talk a lot about SpaceX as we kind of move forward. But just thinking about the rocket process, this is a great example of Newton's third law of motion. And SpaceX has done something really cool. So let's just first talk about, this is the shuttles that NASA no longer launches out into space. They've discontinued this program, but it's still the same idea that what SpaceX is doing. They're just more of an independent company versus government with NASA. So the action is that there's combustion coming out of these big, huge fuel rocket propellers, if you want to think about it that way, meaning that they are burning a lot of fuel to create a lot of heat, which then pushes down on the ground and causes the rocket to rise up. So the action is the fuel comes out, it's burning, it's super hot, it pushes on the ground and causes the rocket to go up. So this is a great example of Newton's third law of motion. I'm going to take it a step further. So if you think about SpaceX, they have done something really, really cool, is that they have made this portion of the rocket re-available, meaning that when these would go off with NASA, they would like fall somewhere into the ocean, and that would kind of be the end of it. SpaceX has been able to launch these into the sky and then bring them back down on a landing pad to be reused, which is super, super smart because they're saving a ton of money that doesn't have to go into rebuilding some of these propelled rockets. So something really cool, and we'll talk about the advantages and the technology behind it. So they've now been very successful at launching and then landing rockets, and now check again, they have been able to launch and dock onto the International Space Station and then undock and successfully bring 2 astronauts back down to Earth. Their next big one is Mars. I know it was Mars 2020. I don't know if that's going to happen or not, but we can cross our fingers and see what this company will be able to do. So let's just take a look at another example of Newton's third law here. So if we think about a raft, and let's say that you're standing on the raft, and it's clearly floating in water, so it's not a stable surface. And let's say that you jump out in direction A, the boat is going to move in the direction of B. So what principle does that illustrate? So for every action, you jump out, there's a reaction, the boat moves the other way. So Newton's third law, there's an action and the reaction. Same thing with these 2 skaters right here. If we take a look at, there's some information that's been kind of added here. We can see their mass. The boy here is 48 kilograms. The girl is 40 kilograms. And if we think about their hand in hand, and if they push off of each other, what's going to happen to them? I'll give you a second to kind of think about that answer. And so that kind of leads us to the end of Newton's 3 laws of motion. We are going to discuss and take a look at how they can all be applied to different scenarios so that we make sure that we're understanding the whole concept before we move into how all of this motion is connected to energy. So hopefully this was helpful. Thanks.